Doing something. Factoring. There we go. Okay. So what we cannot do is this. Now, in this problem, I am sure students did that, and they got possibly the right answers, but they didn't give them points because they did a huge algebraic error. That algebraic error is trying to divide both sides by a variable quantity. Okay, does that make sense? So remember, we did that early in the year, and I said, oh, if we had x squared equal 3x, can we divide both sides by x? And the answer was absolutely not. So what we have to do is factor. So did you factor out an e to the negative t? Okay, so go ahead and factor that out if you didn't. Factor out an e to the negative t. 0 is the only beautiful number because it's the only number you can get an equation to where you can set each of the factors to 0. So we're going to set e to the negative t equal to 0. And then we're going to set cosine minus sine equal to 0. Period if you get a chance to kind of look at why, and then you can move back.
All right.
Okay?
Thank you.
You're welcome. So, e to the negative t, when's it equal to 0? It isn't, right? Why not? What's e to the negative t look like?
1 over something never equals 0.
Right, because, oh, okay, so 1 over e to the t you're thinking, and if you graphed it, it would be a decay exponential function, which is never going to be equal to 0. So they wanted to see that. That's never equal to 0. When is the cosine and the sine the same? Or when is the tangent 1? Pi over 4 and 5 pi over 4. So those were the solutions. Now, the context of this question, I believe, because this was a really small part of free response number 4 in 2007, it was non-calculator. And I believe it asked them maybe for relative extrema or something where they had to find the derivative. So this was the derivative, and they were setting it equal to 0 to find critical numbers. But this is the part that fell apart, so they couldn't do the rest of it. Okay? Any questions there? So go ahead and try the next one if you didn't yet. It's going to be very similar, but this time we're solving for A, and there are 2 different ways you could do it. So see what you think, and I'm going to continue giving some things back to people. Solutions. Sometimes period book has them to use, so you can check those and try to figure out, how to do them correctly. And if you have questions, let me know. Those were the corrections. And look at the solutions and you can try to figure out how to do those before you retake it. That would be good. And then I will keep your test and you can have that back to study. Okay, and then you can let me know whenever you're ready. Okay, so what do you think? Think you got A? Tell me one way you could do it. Factor out an e to the negative t. Did anyone do it that way? Okay. Did anyone start it a different way?
I just got everything to one side and then divide it by itself.
Good. There are 2 ways to do it. It really doesn't matter which way you chose. So Brandon's talking about this way where if you're solving for A, you can get the thing that has the A by itself, just like we did with the dy dx. But we just want the A, everything else to the other side. And then when you do that, you will have to simplify the other side. Some things will cancel out. Why can I divide now? Because they're what?
They're like the same quantity, just there's two of them.
Okay, and why did I say we couldn't divide up above, but we can divide here? When we divided up above, what happened to that e to the negative t? It's gone. It's gone. Here we're making it equal to 1. Okay, so that's the difference. When we did identities, we talked about that too. Does that make sense? Okay, so if you did it that way, you'll get a half. If you started it this way by factoring, factor out the e to the negative t, you'll see stuff cancels. Then I figured out a cosine was also in common. And then when I set that negative 2a plus 1 to 0, I'll get a as a half. Okay, any questions there? So this was 2007, number 4. So at some point, maybe we can take a look at what the other rest of the question looked like, because that was a really, really not good one for students. So that caused some problems. Any questions? Okay, before we do the notes today, let's go over questions from 35 and 36. So last night's homework was a review. We are getting ready for our Chapter 5 test. Today is the very last section that we need to know for the test. So this was a nice review of the first 5 sections, and it mixed it up, didn't it? Okay, so see where you have questions while this is opening up.
I have a question on 8 and 10.
8 and 10. Okay. 8 and 10. Think of your list to see if we need to add more to it. Eight and 10. And then yesterday I gave back some stuff, so I made sure. I posted the solutions to the small gold-free response packet online. I had talked to everyone yesterday about some people not doing their own work on it and looking up solutions and copying it. So I stopped grading it because I couldn't get a true grade for some people because they weren't really doing it themselves on their own. So make sure when you do those free response, do it yourself 15 minutes. We're only trying to make you better. It doesn't matter what that number is. We just want that number to get higher. Okay? All right, let's see. Oh no, okay, so then you can go to your folder when you're finished, so then I'll give this back with your test when I give everyone else's back. Did I give anyone that wanted to do the retake their materials back? Okay, so I wanted to grade those and get those back to you first. Okay, so I heard what, 8 and 10? Yes.
9 and 11.
9 and 11. So 8, 9, you're making this easy for me. 8, 9, 10, and 11. Okay, anything else? 6. Okay, so let's check out 6, 8, 9, 10, and 11. So the first one, oh, you know what? Let's just talk about a few prior to that. Number 1, did you use the properties of logarithms?
Yes.
Good. Someone said they didn't, and then they wrote themselves a big note at the top of the page. Never do that again. Use properties of logs, okay? Because if you didn't, it would have been much more difficult. So this is a really good one, number 1, okay? The second one you could not do unless you did what? Properties of logs again, right? You couldn't even integrate it if you didn't do that. Okay, so really, really important in this chapter. 3 was just a U sub. 4 was just messy, right? Lots of E's. Lots and lots of E's. Okay, 5 was a differential equation. You were just solving for dy dx, finding the derivative. 6, integration. 7, how did you have to do that one? Monomial division. Good. Okay, so there was a question on 8. This one was just really weird to square. If you're squaring e to the x minus e to the negative x, I just wrote it out twice. E to the x times e to the x is e to the 2x because we add the exponents. Then we'll have minus e to the negative x plus 0 minus e to the negative x, plus x, which would be what? When you add negative x plus x, you'll get, when you combine e to the x times e to the negative x, that's e to the 0, right? Because you add the exponents. That's what tricked people Earlier, yeah. So this is going to be minus 1, that's going to be minus 1. Because when you have bases that are the same, you add the exponents. Do you see that now? So then that's minus 2, then this is plus e to the negative x. You have to take the dx to the other side when it's a differential equation. When it's an AP free response, I don't give you any points if you don't do that, because you can't integrate with respect to x without that dx there, and with respect to y without that dy. So y equals, and then I split it up into 3 separate integrals. Does that help? I think it was the squaring part on that one that was tricky. We're just not used to doing that very often. Number 9, you can't do a thing with until properties of logs again, right? Make that 1/2 ln of x over x, and then it works real nice with u substitution. Does that make sense on how to fix 9? Okay. 10, this one was implicit differentiation because the x's and y's were all mixed up. So on this side, I had to do the derivative of cosine of u, which is negative sine of u times u squared. The right side, I had to use the product rule, and when I took the derivative of a y, I had to attach a y prime. The only thing that had a dy dx, I'm going to take to the left side and then solve. Any questions on that one? And the last one, did someone need 11, the inverse one? Okay, so 11, the inverse, I found the inverse by flip-flopping the x and the y, and then I couldn't do anything. So I found out when x is 2, y is 1. So on the inverse, when x is 2, y is 1. So using the formula, 1 over f prime of f inverse of 2, f inverse of 2 is 1. So then I did the derivative of the original, 3x squared plus 2, but I put a 1 in its place to get that answer. Okay, any questions? All right, so the last section of the chapter, we're going to go to page 47, and what we're going to do is look at the 2 new formulas. So you need to add these to your cheat sheets. There are 2 formulas that we need to memorize. There really are 6. However, we're going to learn 2 of them. Why do you suppose I'm not going to ask you to memorize one for arc cosine? It's the same but negative. So I could make everything in an arc sine instead of arc cosine. And then we don't use the reciprocal ones as much. The only other one I've seen on the AP test is arc tan. So we'll stick to 2 instead of 6. They're awful. Okay, so 2 is better than 6. But what you want to recognize, and what I start to do is we put all this integration together, which we're going to do today. If you see a square root in the denominator and u sub doesn't work, then we want to look at this. See if it's some number squared minus u squared, then we could put it into arc sine. If we have a denominator that's something squared plus something squared, we can possibly use arc tangent. No, we don't always want to jump to these. We still want to think about monomial division, simplifying the integral. Does u sub work? Can we divide? Like all of those little tricks that we have, but we're going to add these 2 things. So what we're going to do today is add these 2 and then really start to look globally at these integration problems and try to figure out, how to do them. This is where some students, starting with chapter 4, start to have difficulty because integration isn't, here's a formula, use it. Integration is, it's a puzzle, figure it out. Okay? Which of the methods that we know should be used? That's where it's fun. But not everyone sees the fun, okay? But it is. What we'll do before we take the chapter 5 test is we'll go to chapter 8 and do section 1 because it's the same as this section. It's just more integration, all mixed up, and then we have to figure out what way to do it. Okay? Yeah, so we're going to start off real basic, looking at those formulas. So looking at those 2 formulas, that first example looks like it might fit into which one? Mm-hmm. What would A be? What would U be? So du is dx. So what the nice thing about this one is we don't have to balance with anything. And it's going to fit perfectly into that arc sine formula. So our answer will be arc sine x, look up at that formula to do it, x over 2 plus c. Okay. Now Now, why did I do that? Why wouldn't U substitution work? Because I'd still probably, looking at that, try U sub first on an integration problem of that sort.
You would have to use it, there would be an X because of
Yes, good. Your du would have an x in it. We don't have an x. Okay, we can't create a variable. Does that make sense? But I would still probably go to U substitution for that. Same thing here. Probably say, well, I know I can't do anything algebraically. U sub's not going to work because I get du as 18x. I don't have an x. Not sure what to do. I can't divide, so I'm now going to try this arctan formula. What would a be? Square root of 2. What would u be? Good, 3x dx, right? So we need a, or just, yeah, 3x, sorry, du is 3dx. I'm getting ahead of myself. So u is 3x, du is 3dx. So we need a 3, which means we balance with 1/3. And it fits perfectly into that arctangent formula. Which, look at the formula. It is 1 over the square root of 2 arctan of 3x over the root 2 plus z. Okay. Questions? Yeah.
Are we allowed to leave this for the denominator?
Oh yeah. Yeah, you could make a root 6 over 2, like, but you don't have to rationalize. Now, if it were multiple choice, and they rationalize, you'd want to just make sure yours matched up. Yeah. Okay, any questions so far? That's using those two. Now we're going to kind of go back to just anything's fair game. So let's try these. See if you can try the next one. Figure out what might work. When you see a problem like this, what would you probably jump to trying? Probably U sub, right? And if U sub doesn't work, you have to cross it off. That's where you have to be persistent and just try something else. So did U sub work? What would you let U be? U would be 9 plus e to the x. Let's see if that works. Yeah, so then that would work, wouldn't it? Because you might look at that and think maybe it was arctangent. But don't jump there first. Go to what we normally have done before you do that. So du over u, the integral is? We've been missing this on the formula quizzes. Absolute value, right? Now in this particular case, I can remove absolute values. Do you know why? It's always positive. Okay. Any questions? So that's just an old one, right? That's clear back from section 4 that they would have given us. Okay, try the next one. What would we probably start by thinking? We probably started by doing or trying U sub, right? Is U sub going to work? No. And trying it helps you realize why it doesn't. Why doesn't it work? Yeah, we don't have an x. Okay, so what's the only other formula that we have that has a square root in the bottom? This new one, right? So what would a be? Square root of 5. What would u be? Good, square root of 2x. Du would be square root of 2 dx. So we have to balance. And then see if you can fit it into that formula. I also want to see if I'm missing anything from people. think you have it? Okay, what is it? Arc sine of root 2x divided by root 5? And you can make that root 10 over 5 if you wanted. Okay? Any questions?
For that, would you also need the 1 over root 2, and you also have to multiply by the 1 over root 5 to make it the 1 over I, right? Or am I
The arc tangent.
Oh, I'm looking at.
Yep.
I'm dumb, I'm sorry.
No, that's okay. The arc tangent has that, and that's really confusing. I get confused actually with that same thing. Arc, which one has the 1 over a in front, which one doesn't? And the arc tan
I'm
does.
just looking at the completely wrong.
I do the same thing because you have to kind of get those straight somehow.
Well, we could think of it as tangent to a, so it has the 1 over a.
Yeah. We can do that. Okay, try this one. See if you can figure out how this one's going to work. U sub might work. Okay, does U sub work? Kinda. For part of it, right? So what can we do? We've done this before, so this one isn't a new trick. What can we do? Well, U sub works on the first one, right? How do I get that x and that 2? What can I do? Monomial division. Or it's called separating the numerators. Can't we do monomial division and make it 2 separate integrals? Because this one U sub will work with. Okay, so go ahead and do U sub on that one, and then we'll figure out what to try to do with the other one. We want to keep both parts together, so we don't want to forget the other part. We just need to work on it now. And then Brandon, I collected the gold free response packet. Connor, when you get yours, finish. Marie, same thing, gold free response. Jake, gold free response. And Katie, you weren't here, gold free response. And then I'll give it back, but I just gave points for it. Okay, so this side we can kind of get done with, right? Now I could put a plus C, but if I'm still integrating this side, I'm okay if I just, it's going to be incorporated into this integrals plus C. So what's this one going to work as? Arc sine, right? What's A? U is, so this one works perfectly without balancing or anything. We're going to have 2 times arc sine of x over 2, yes. And definitely, until we know them, flip back. Now, do you notice that we use 2 different u's in this problem? So we don't want to confuse someone that's reading our work. So I would put the u for this one over here and this one far enough there so that that wouldn't be confusing. Okay? Any questions? So that's not a new one, is it? New trick is to separate. So you're going to see more like that. See if you can figure out what to do on the next one. Anyone need this one any longer? Okay. Does U sub work? Uh-oh. We need a new trick. Okay. U sub's not working. We can't algebraically do anything with it to change it, but we can. do we do?
You do like the integral of dx over x squared minus the integral of dx over 4x.
Wish we could. We can't, just because we can't separate a fraction that way, like if you had 1 over 4 plus 3 plus 7, you can't do 1/4 plus 1/3 plus 1/7. So you can't break up the denominators.
So you can't do x to -2 minus x to -1.
Oh no, because that's not, they're not factors. So you can't, it's stuck as x squared minus 4x plus 7, so you can't take x to the -2 to the top, you can't pull it apart. They're being added or subtracted. You can put the whole thing to the -1, take it to the top, and then we're stuck. What can we do when we have a quadratic? You learned it last year. Complete the square. Why would we want to complete the square? Which of the two formulas today would it fit into? Which one's the one without the square root? Arctangent. So we need to review how to complete the square. Now the good thing is this is a 1x squared, and it's easy to complete the square when a is 1. If a isn't 1, this algorithm doesn't work. We have to do something else. But this one, what number is going to complete the square on x squared minus 4x? What number do you think? Well, the formula is to take b over 2 and square it. So what number would that be? What's -4 over 2 squared? 4. Because wouldn't that, when you factor it, be x minus 2 pi squared? We made it a perfect square trinomial. But I can't just randomly add 4 unless I do what? Yeah, there's not another side. So I can't add it to the other side because there's no other side. So instead I could subtract 4. Don't I have that 7 there already? Wouldn't that be the same if we canceled out those 4s? We would just go back to what we had? Okay. So the reason is because this is now a perfect square. X minus 2 squared. We forced it that way. And then we have a plus 3. How would we know, like, where are we going to get this idea that you'll go, oh, maybe I should complete the square? Tell me what things we might need to complete the square. It's not factorable. Good.
The quadratic formula we can't take away.
It's a quadratic. So we complete the square with quadratics, or we could do it with 4th powers too, but it has to be some type of trinomial, like we want to get it to be a perfect square trinomial. And to fit into arcsine and arctangent, both of those have to be where in the fraction? Denominator, okay? Now see if you can get it since it's now arctangent. A squared plus u squared or u squared plus a squared on the bottom mean that that's the same thing. Questions there. So if you have a quadratic, that's a good choice to complete the square. Then yesterday I collected the mega multiple choice. If you weren't here yesterday, make sure that I get that. I'm going to give you back a bunch of formula quizzes. I haven't done anything with them yet, but we'll take like the top 5, so it'll be a 50 point, like a test score. So like your lowest couple will drop. Okay, we're missing Ethan, Morgan, Sasha, Jacob.
I didn't know Ethan's on the field test.
Okay. Yeah, he told me, and we're gonna do. All right, so the next one, what do you think? Will you sub work? Oh, we don't even know what the integral is. Whew, we have to figure this out. Find the area bounded by that curve. I don't know what that looks like. The x-axis, I know what that is. X equal 3/2 and x equal 9/4. Do I really need to know what that function looks like? No, but what do I do know about it? Where would it live? Above the x-axis, because any numbers you put in, we're going to get positive y results. So what does that mean in symbols? The area under the curve means the integral from 3/2 to 9/4 of that function. Because it's the area under the curve to the x-axis. Those are the only areas we know so far. We're going to learn in chapter 7 how to do area between two curves, but we don't know that yet. Okay, now what? Will U sub work? No. But it's a quadratic, and it's in the denominator, and we're in the inverse trig function section, so guess what we're probably going to need to do? Complete the square. But this one's a harder one to complete because A isn't 1, is it? No, A isn't 1. So yeah, I'm going to give you back a bunch of them, but remember we're dropping the lowest couple, so. What do we have to do to this before we could complete the square? We can't have, this has to be a 1. Yeah. Okay, so whatever's in front of x squared, it doesn't matter what it is, it needs factored out, or the algorithm for completing the square doesn't work. Try to figure out what completes the square. Take b over 2 and square it. 9/4, okay, so if I put 9/4 in there, what do I have to do to keep it balanced? So I'm adding 9/4 here, but I'm really subtracting 9/4, so what do I have to do outside? Add 9/4. Because what you want to do is if you multiply this back out, you want to get negative x squared plus 3x. Okay? So we're going to go into the integral, and we're going to rewrite that as, I'm going to do a squared minus u squared. So it's 9/4 minus, what's the quantity? What's the number that has to go? So when you square it, you get 9/4. 3 over 2, right? That's the b over 2. And we're going to have to do x minus to make it be a minus. Now which formula does it look like it works into? Arc sine, go ahead and try it. See if you can get it in arc sine. That's the one with the square root. And maybe you can use these practice quizzes to practice a little bit more, cover up the answers and do like a little, or make flashcards, or, and it's not fun to memorize, I don't like it either, but there are just a couple things we have to do that with. And these formulas are some of those things. Okay, so A is 3 over 2, and U is x minus 3/2, good. And luckily, we don't have to balance with anything, right? It's going to work right into that arc sine formula, which is arc sine of, so I could change this to U's. I don't really want to do that because then I have to tie these here, but I could. A squared minus u squared du. Okay, it's going to be arc, which one? Sine of x minus 3/2 over 3/2 from 3/2 to 9/4. Okay, let's put in the 9/4. So we'll get 9/4 minus, what, 6/4? 9/4 minus 6/4, 3/4 over 3/2. The other one's easier, thank goodness. If I put in 3/2, what's arc sine of 3/2 minus 3/2 over 3/2? Oops, to write the rest of it. What would that give us? 0. What's 3/4 divided by 3/2? 1/2?
Yes.
Ooh, so we need to know what angle has a sine that's 1/2. And then what angle has a sine that's 0. So which angle has a sine that's 1/2? Pi over 6. What angle has a sine that's 0? 0. So the answer is pi over 6. Okay. So do you see how they're going to combine earlier, like last section into this, where you need to know a little bit of trig? Any questions? Okay, so the homework, if you look at the worksheet, flip the page, 1 and 2, let's take a look at those for a minute and see which formula would number 1 work into nicely. Number 1 works into which formula? The arc tangent, right? So do the arc tangent on that one.
0 over
And the second one is, so first one's arc tangent, second one is arc sine. See if you can get those two. When you go to do the homework, I want you to do the worksheet first because it's easier. All right, then the book work gets a little bit tougher. And then I'm going to look through the cards. We're going to be at the end of the 9 weeks, like in a week or so. So I'll end presentations. Let me tell you who needs them the most while you're working on 1 and 2. And then flip the page and see if you got them right. Because the answers are on the next page. So let's see in terms of the cards. Someone has 4. We'll take them out. 2, 2, 2, 2, 5, 1, 2, 2, 1, 1, 1, 2, none, 3, 3, 3, 3. Okay, so first chance for tomorrow. Brandon, Jacob, Jake, Ryan, and Sasha's not here. So those 4, 33. Ryan, thank you. Brandon, 37. Jacob's not here. Jake, 39. And anyone for 43? One more, Matt. All right, guys, have a great day. Do the worksheet first because it is easier. It kind of builds you up and gets you used to those formulas. They get harder.
Because everything always gets harder.
And then tomorrow we'll mix it up. We'll do derivatives and integrals of inverse trig functions. I bet you can't wait.
This summer, right?
Yes. Yeah.